Welcome everybody to our webinar delivering on accurate localization for autonomous vehicles in all conditions everywhere. Today, very first time I want to introduce our Terran360, the new Navtech-Oxbotica radar localization solution. It brings together Navtech's high-performance radar technology and Oxbotica's world-leading autonomous vehicle software platform to deliver centimeter-accurate localization in all weather conditions and all environmental conditions. An off-the-shelf solution which integrates into any autonomous stack. It operates entirely independently and so does not need any GNS or GPS. Using Terran360, mapping your site is simple and infrastructure free. There's no need to install physical beacons or markers. With its increased accuracy and reliability, it can help you to increase the safety, productivity, and efficiency of your operation. So in this candid webinar today, we will have 3 panelists, and it's hosted by Navtech Radar founder and managing director Phil Avery, and Oxbotica founder and CTO Professor Paul Newman, who will discuss how they joined forces to develop a new radar-based localization solution that is unlocking the full potential of automation with proven accurate localization. We have a short video to show and illustrate the capabilities of Terran360, which we want to show you now. Thank you. Let's start to get more insights on the development of Terran360 and why is it a groundbreaking solution. And I want to start with Phil. So could you tell us about the development of the product? Why is Navtech saying that radar-based localization is groundbreaking?
Thank you very much. Actually, interestingly, Navtech was founded with the intention of developing a radar for this kind of application. It was over 20 years ago. Nothing quite like we have today, but it was a rudimentary localization solution for a port environment, and the radar was chosen for that because of its all-weather capability and long-distance sensing. In that particular application, you had to survey in specialist radar reflectors in a controlled environment that was set up just for radar localization. So that's where one of the initial applications that we sold the radar into, where we started. So the radar was chosen for that because of its capabilities. Obviously, nowadays that wouldn't be acceptable. You need to have a system that will work in all environments where there isn't a specially prepared environment with radar reflectors and things like that. But the benefits of that solution, i.e. being all weather, long range, all light conditioned operation, is still there, but with the addition of the capabilities of actually working in all environments, and that is not offered by any other solution.
Yeah. So the Terran360 is a result of a collaboration. It's a result of Navtech's 360-degree high-resolution radar and Oxbotica's world-leading autonomous vehicle software. Tell us, how did Navtech and Oxbotica come together to develop this product, Phil?
Well, actually, Paul and I met some time ago, around actually the time that, just before the time that Navtech was founded, so around 23 years ago, or maybe a little bit more actually. And we've kind of stayed in touch since. So I've been working on radar technology, and Paul was, and obviously still is, working on autonomous vehicle technology. And I guess we've compared notes over the years. And it became apparent not so many years ago that actually this would be an ideal combination of Paul's software, Navtech's hardware could deliver a solution that wasn't achievable, with the performance that wasn't achievable in any other way. And that's what we've done with Terran360.
So just to recap, you met roughly 20 years ago, and it took you so long. I don't assume so. So I go to Paul. So what was suddenly different about radar that made you adopt it as a key sensor for localization?
So thanks, and hello everyone. So I guess that I've been thinking about large-scale field robotics for most of my professional life, and founding Oxbotica back in 2014, the vision was always make machines do more, make bits to move atoms, so large-scale automation using different sensors. And we started by using vision, and we started by using laser, and those are great solutions. And radar was for a long time quite elusive. And one of the things, it's a very different sensor to laser, and a very different sensor to camera. And it's got these properties that Phil talks about in terms of being able to penetrate rain and dust clouds and work everywhere that you might ever want to deploy it. But it's a very rich sensor. So it's a complex sensor. It's not like a laser, you fire it, you wait for those photons to come back and you get a range. The beam shape grazes and interacts with the ground in quite a complicated way. So it took a while to figure out ways in which we could leverage that complexity rather than thinking of it as a noisy sensor, which is just stupid thinking. We started to think a bit smarter and go, actually, it's a very rich sensor. How can we leverage that? And then what we did is we put this into the back end of Oxbotica's navigation stack, where it can leverage all of the mapping, all of the tooling that we have for large-scale automation, and have radar as that front end there. So really that bringing together of things we've been working on for a while, some new mathematics and new ideas about how to do this with radar. And then the sensor from Navtech was extraordinary. And, and we've ended up getting it running on a 1-watt processor, which is quite something. So it's really come together there.
When did you realize it's extraordinary, and what kind of tests did you put to the radar so to know that it really works?
Well, it's been in test in Fury for about a year now. We've put it on the fronts of trains, we've put it on boats, we've put it on vehicles through cities, we've put it in power stations, we have put it through towns, we put it on motorways, almost everywhere we've run it up to 120 miles an hour. And then very slow speeds. We put it through oil refineries, and we run it on across our fleet of vehicles and with other people's vehicles as well. So it's been fairly rigorously shaken down by lots of people in different environments.
Thank you. And that brings me to our next panelist, which is Mike from BAE. And you are one of the first customers who started testing it and piloting it. Why did you choose to try this localization solution? Because we all know there are other technologies available out there. Why the Terran360?
Yes, so my field of interest is autonomous surface vessels. And with these, you find that space, weight, and cost are always at a bit of a premium, an area of concern. And this Terran360 solution offers us really a bit of a unique opportunity, because it combines the benefits of a high resolution radar with a localization solution, sort of in one fairly compact package. And we've explored some of the other technologies for GPS resilient navigation, but most of them either tend to be fairly poor on performance or very high in cost, and this represented really a bit of an optimum in that, in terms of something which provided an all-round good outcome.
And so it's a commercial use case we talk here about. You put it in a boat. What was the challenge you were looking to address specifically? Can you tell us a bit about the specific example?
Yeah, so one of the first activities we did was to choose quite a complex operating environment. So we took it to the River Thames in London. That's a complex and congested environment, and unlike the automotive or mining sector, where you've got quite a lot of build features. The river varies between maybe 200 meters in the city center out to about 500 meters across. So you tend to have a very sparsely populated near field with a lot of rich infrastructure content further away. So out of the box, that presented some challenges, but the Phil's and Paul's team rose to the challenge, I guess, and tweaked the software really to focus on features that were maybe further away than they were anticipating. And we got some surprisingly good results. So I'm sure Phil will talk about accuracy in a minute, but down to sort of, centimeter, certainly decimeter accuracy over very long extended periods. So we did a 3-day trial. And over many hours, we were still getting accuracies of within, the size of my hand.
Yeah. And it was also about reducing your reliance specifically on GPS, I understood. Also, tell us about the moment you realized the application was really working for you.
Yeah, so, I mean, River Thames is sort of a fairly unique environment. There's an awful lot of bridges you go through the city centre. Going under a bridge is a unique experience for an autonomous system because you've got pylons that present a significant risk of collision if you get it wrong. You've potentially got something else coming the other way, and just when it gets scariest is when you can no longer see the sky and you lose your GPS signal. So having that sort of resilient backup without having to rely purely on an inertial navigation, which suffers all the typical problems of drift and also being relatively expensive. Just having that fail-safe backup is a real benefit.
And as we all know and can imagine, on a ship you have quite a lot of systems needed. So how easy was it to implement the Terran360?
I think this was one of the beauties of this. It was very quick and easy to get it up and running, sort of straight out of the box, and within an hour you've got something which is basically operational. We use radar track extraction Cambridge Pixel software, and that was really beneficial as well because obviously that's sort of natively supported by the software. I think in terms of a system integration of an OEM product, it almost couldn't be simpler.
Good. And what was the impact it had on your operations?
I mean, it's early days yet. This is still a pre-market product when we evaluated it. So very, very promising early results. We need to do further field tests, but it gives us the potential really to recover from two problem circumstances. The first, when geography prevents you from getting a GPS signal for benign reasons because you can't see the sky or because there's just too much high-rise buildings around, but also the circumstance where you might have active interference. So again, in a sort of urban environment, it's not inconceivable that a man in a white van might be taking a coffee break and not want his bosses knowing where he is, and he switches on his illicitly bought GPS jammer and sat on a bridge. That's just where you don't want it to happen, and so it just gives us that sort of redundant mitigation solution for what is effectively a safety critical system.
Thank you, Mike. I want to go back to Phil. We have heard now from Mike about the positive impact of this technology from BAE's perspective. So it's in a maritime environment and use case. But what other proof of concepts has the product been through? And can you give us an idea how does the Terran360 overcome challenges in, for example, underground mines, which is one of the proof of concepts I know you were doing. Share a bit more about the other proof of concepts.
Thank you. Yeah, we've been very fortunate actually to have done a number of proof of concepts in very different environments. So Mike has mentioned the one for surface vessels, and interestingly, the benefits that he's seen are similar across the other applications. So we've had it in on underground mining vehicles. Clearly there is no GPS coverage at all at any time, let alone underneath the bridge. You just don't have GPS. And you also have an environment where there is often lots of dust in the air. There other GPS won't work, and normal visual sensors won't work either, and therefore it provides a reliable solution in that environment. We've also tried it on the front of a train. Interestingly, localization of trains is quite a tricky problem because you have high banks, you don't get good visibility of GPS constellations. There's lots of tunnels, tree coverage, all those kind of things like that. And the vehicle's moving quite fast in a narrow corridor with close-in targets, which again is the opposite to the situation with surface vessels. We've tried it in open mining environments, port environments. The range of applications we've tried is quite varied. And in all cases, it's about that circumstance where you've got adverse conditions, you've got no GPS coverage, you can't see. It will always continue working, adding that level of reliability and performance that you're not going to achieve elsewhere. And those things happen more and more, particularly in mining environments. It's a regular thing that you have a blasting or something like that, and the mine is full of dust. And similarly with other mining applications and even port applications, if you want to work 100% of the time, then yeah, you're not going to be able to rely on traditional technology.
So I understand it's increasing productivity, but it's also about improving safety.
Yes, absolutely. I mean, if you've got an automated environment, you really don't want things to bump into each other. Arguably, you could say you need the system most when visibility is poor. If there are any humans involved, clearly that's an issue. So safety is improved massively by this technology.
And I assumed already one of the questions from the audience, but it fits here very good because it's asked, does it really not need GPS? So whom of you
yes, it really doesn't need GPS. maybe I can pass over to Paul there, and no, it really doesn't.
It can localize without any GPS, so you can build a memory, build a map of a place sans GPS, operates and can boot itself without GPS. So it can initialize itself without GPS. Now, if you wanted to say my entire mine site works in a UTM coordinate frame and a GPS coordinate frame, you need to tie the two things together in some way. So you have to say, oh, by the way, this point is at that long, okay? But that's just a coordinate frame matching and working any coordinate frame for doing that. But certainly, like on the autonomous vehicles that we operate, there's no GPS at all. So it works entirely just off the radar as well. But if you want to reference it into a GPS frame, at some point you must have used a GPS to say this point is a GPS, but you don't need it at runtime. That's really important, nor to boot the thing. And that's definitely sort of an ethos that we have inside Oxbotica, is that localizers must run independently. They can't be codependent, otherwise you're going to end up in all kinds of trouble. And of course there isn't a GPS under mines.
And I think in that arena also fits, again, elaborating a bit on the groundbreaking, and it's 100% reliable. If I would really squeeze you, is it really 100%, or are there any circumstances where it would not work?
I like this question. So where does it not work, right? That's the obvious engineering question. So the radar has to see reflections. There has to be something in the scene that reflects energy back. So a place where it would not work is totally reflection-free ground. That's not by, for example, a field, because stones reflect. Okay, but it would have to be something. When we took it to Iceland, actually, way back, we took one of those radars, and it's very icy and very flat, and it was fine there. But since then, when Oxbotica have been working on this, I think the hardest place was initially when we tried it in the middle of the Thames, because Mike did a good job though. Couldn't see anything for 200 meters on either side most of the time. But it's not really so much tweaking, that's like an installation. It was like, okay, so actually these are different operating conditions, and that seems fine. So the fundamental point is, if there's something in your scene that reflects EM radiation, it doesn't have to be metal, it can be stones or foliage, then it gets a lock. It's also, of course, introspective, that it'll tell you whether things are working well or not. So it's got measures of confidence about how well this is going.
And just to build on that, we have seen in the little video that it also can get dirty. What is the degree of dirt, which where it still works, or does it always work, or is there a limit?
Phil, that's definitely you, man.
Yeah, I can comment on that. So I mean, there is a limit. If you were to absolutely cake mud on the outside of it and make it a couple of inches thick and let it dry, I suspect it wouldn't go through there, particularly if there's anything conductive in the mud. So, I mean, in some mining environments, potentially you could create something that it wouldn't go through. We've actually used it in iron ore applications for controlling automated cranes, and there it gets caked in iron ore and it works fine. So it has to be pretty extreme before it'll stop working, but it is possible. You can put enough stuff in the way of the beam to stop it working, but you know, it's a lot.
Yeah. Okay, understood. So I would like to go now to the questions from our attendees of the webinar, and one which is fitting. Do you see issues when working in an environment with many metal surfaces, so reflections, ghost targets? Is that an issue?
No, that's great. That's perfect, because if I were to pick something that reflects, it's called metal, right? And so the mathematics in there deals with the fact that it's expecting and looking for, I think someone called it, you know, ghost reflections. Absolutely. The more stuff it sees and the richer the return. It might look really confusing to a human, but this is inhuman, right? It doesn't work like, you know, laser matching used to. It works completely differently. So yeah, no problems there at all. And no problems with moving. If everything moved and all it could see was movement, well, then that's a bit confusing. There's nothing that's still in the world, but it looks for things that are still.
I was just to say, Paul, I think it's to your point you made on a number of occasions, you're not trying to make it look like a LiDAR. You're not trying to convert the radar data into LiDAR data and have a nice simple point cloud. That's not how the system works. So consequently, complex environments with many reflections, as I say, are good. They're not bad. It doesn't confuse the system.
Another question fitting into this from our audience is, how is the communication with the control center to get the localization of the moving device?
Okay, I can help with that. Why don't you think about this as just like an uber smart sensor, and has an output stream. You can have that in NMEA or whatever format you want, and it says this is where I am as a message. Okay, and we're very flexible and no problem at all to change it into whatever format you want that over whatever media. And so this is something that's plugged into something on the vehicle. Now, whether you want to then reflect that over a radio modem or 3G or 4G or LTE, or keep it totally secret squirrels to yourself in your own vehicle and not broadcast that, that's entirely up to you. So just think about this as a GPS replacement, that, you know, you have a GPS on a vehicle and it has an output and it tells you where you are. It also tells you how you're moving as well. So it gives you your velocity, it gives you your yaw rate, and, you know, yaw's down to a fraction of a degree. As well, so that's the think of it as a fancy GPS that doesn't need sky.
There is question about the use cases. So one of the question, do you have example by using it in airports, for example, or any other areas?
We've used it in many. I mean, Navtech have done a number of proof of concepts, and I know Oxbotica have used it in many different areas. But airports would be fine. There's plenty of reflections around in an airport. Yeah, I guess the largest open space would be places like the Thames, where you've got nothing for several hundred meters before you start getting reflections. As Paul was saying, I don't think, unless you've got an area where there are no reflections or where everything is moving. So in the middle of the sea, for example, it wouldn't work in the middle of the sea because you would see the waves, but of course they're moving all the time. They're not in a fixed reference. So it wouldn't work there. But pretty much in every other environment where you've got, I wouldn't say infrastructure, but fixed items, almost any items, then it's going to work.
And again, a specific question on a use case. So can this technology be used across port operations? So including ship docking, warehouse operations, and then also the area of traffic around it?
No reason why not. I don't see any of that being a challenge there. I mean, the combination of those would be fine. Yeah. And ship docking as well. So interestingly, we do have customers who are looking at using our technology for ship docking for that last sort of maybe 50 meters of docking. Yeah, no reason why it wouldn't work for that at all.
Yeah, and that's the high resolution of the sensor really aids that. for close-in navigation, only down to that like sort of less than 100 meters, far superior to conventional navigation radar.
Good, thank you. We have unfortunately only time for a last question before we have some closing remarks. Choose this one. Can you compare LiDAR and radar from a cost perspective? So I think the question goes on the costs of introducing Terran360 in any use case.
I mean, I could, Paul, maybe that's better for you, as you've actually used many different sensors. Obviously, I focus mainly on just the radar. Cheaper.
Yeah, I think it's cheaper and in some ways better. Like, it's never like, you know, all things are better in all directions, but there's a reason we're starting to use this radar everywhere. Yes. Also, it's been the great thing about this that we like is that this sensor's been out in industrial automation for 20 years. You know, it's proven. It's it's been running ports in Australia for 20 years. So yeah, great in that sense too.
Thank you. Thanks to all three of you. Unfortunately, I'm very sorry, but we don't have time for more questions. But as I said earlier, we will answer each of them offline. And as also mentioned earlier, we will share the recording to everyone who has registered. And if you have any questions or you would like to discuss a trial, then please email us to Terran360navtechradar.com. So please contact us. We are looking forward to that. Again, thanks to our fantastic panels. Thanks to everybody involved making that happen. And thanks to everybody who dialed into this webinar. Take care and goodbye.